Okay, well, here we are. Hello and welcome. This is free SO2, another webinar presentation. I am Aaron Essery, Assistant Extension Specialist for Viticulture and Enology here at Oklahoma State University. So let us begin. So, free SO2 is free sulfur dioxide. So what is free SO2? Free SO2 is the amount of available sulfur dioxide in wine to protect against oxidation and microbial spoilage. Available is the key word there because there is a such thing as bound SO2 in wine that offers no protection. So you need free available sulfur dioxide in wine, hence the name free SO2 or FSO2. So if you see free SO2, that's your available sulfur dioxide in wine to protect against microbial spoilage and oxidation. So FSO2 protects against microbial spoilage and oxidation. Thank you for just joining us. We just started. So, okay, how does free SO2 get into wine? So free SO2 is added into wine, usually in the form of potassium metabisulfate. Shorthand is KMBS. KMBS is widely used in all winemaking industries around the world. I mean, everybody uses it. There's also a such thing as gaseous SO2, but this is much less common. Only really large, big wineries or research wineries, labs use gaseous SO2. But for the most part, it's just potassium metabisulfide, shorthand KMBS. Okay, so I'm going to spend quite a bit of time on this slide here because it's kind of important and it's somewhat tedious to understand. But anyway, so SO2, sulfur dioxide, exists in three different forms. There's the bisulfite form, the molecular SO2 form, and then a form just called the sulfite form. But the sulfite form really doesn't exist at wine pH. And this is where I'll really dive deep into this. So it's the molecular SO2 form that is responsible for the antioxidative and antimicrobial effect that we all know and love as free SO2. So this chart on the right, the bottom x-axis, the horizontal axis, shows a pH from 0 to 10. The y-axis shows, or the vertical axis shows percentage in a given form of sulfur dioxide. So wine pH usually exists between 3 and 4. We all pretty much understand that. If you follow these lines here, excuse me, the blue line is your molecular SO2 form. The pink line is the bisulfite form. So you see how the form of sulfur dioxide is dependent upon pH. And when we're dealing with wine, we're dealing with a pH between 3 and 4. So most of our SO2 in wine is actually in the bisulfite form, which doesn't offer the best protection. In fact, it offers really no protection against oxygen and microbial spoilage. It protects against like acetaldehyde and sugars and stuff. But if you're looking for antimicrobial and antioxidation effects, you need the molecular SO2 form, which, if you follow this graph, between a pH of 3 and 4, only exists at less than 10%. I know this is a little hard to understand, especially if you've never seen this chart before, but there are 3 forms of sulfur dioxide. And when you put potassium metabisulfite in wine, most of the time, you actually have less than 10% of molecular SO2 to protect your wine. Does that kind of make sense? We'll have a slide here where you can ask a quick question here in a minute. But I just want to try to drive this home that at a wine pH between 3 and 4, you actually have less than 10% of available molecular SO2 to protect against oxidation and microbial spoilage. And I'll hit on this more and more as slide goes on. See, if you shift your pH above 5, which no wine should ever have a pH above 5, but if you were to shift it above 5, you would start hitting that sulfite form, and your bisulfite form would drop off. If you just follow the lines, the yellow line is the sulfite form, which is non-existent at wine pH. But you see how your forms of sulfur dioxide shift depending on pH. So the main thing I'm trying to drive home here is at a pH between 3 and 4, which is wine pH, you have very little molecular SO2, which is the real good stuff. It's mostly in the bisulfite form. We'll continue on this. So again, pH affects molecular SO2 concentrations. Molecular SO2 is more abundant at a lower pH than at a higher pH. So this is another graph kind of explaining it, but look at the pH ranges. Look on your horizontal axis. You have a pH of 2.8 between 3.8. Now, wine probably doesn't exist at 2.8, so just slide into 3. So between 3 and 3.8, this is kind of your wheelhouse for all wines. If you look here, let's go to a pH of 3.5. Okay, you have a pink line and a blue line. This is saying that at a pH of 3.5, if you were to add 40 ppm of SO2, you're actually only going to get 0.8 ppm of molecular SO2 at a pH of 3.5. The rest is going to be in bisulfite form. Does that make sense? So the x-axis is your pH, the vertical y-axis is your free SO2 ppm. Milligram per liter is the same thing as ppm. So if I want to make a 40 ppm addition at a wine pH of 3.5, I'm only going to get less than 1 ppm of molecular SO2, which is the real good stuff. The rest is going to be in the bisulfite form. And there's really nothing you can do about that. That's just how it is. That's how sulfur dioxide interacts with pH. If you were to slide upward to a pH of 3.8, my screen here, you can see, if I have some banners in the way, but if you were to slide up to a pH of 3.8 and make a 80 ppm addition, you would still only get less than 1 ppm of molecular SO2 at a 3.8 pH. I hope that makes sense. I know it's a little difficult to understand, but the higher pH you have, the less molecular SO2 available. You'll have a lot of bisulfite available, but very little molecular SO2 available. So I hope this is making sense. We'll have a Q&A here at the end. So which brings me to a pH, a wine pH above 4.0 is bad. If you have a wine that has a pH of above 4.0, KMBS, SO2, free SO2 is essentially ineffective. Because again, look at our chart. If I have a pH of 4.0, I have almost 0 molecular SO2 available. Does that make sense? I hope so. So KMBS offers very little protection at a pH of above 4.0. This is why it's very important to know your wine pH. When people ask me, they say, hey, I want to make wine, the first thing I really recommend is a pH meter, because you need to know the pH of your wine, especially when it comes to your KMBS, your potassium metabisulfite additions. And my slides have stopped shifting. Okay. There it is. So again, if you have a wine at 4.8 or above, you have almost no molecular SO2 available. Okay, so the bisulfite form versus the molecular SO2 form. Again, these are the two forms that are dominant at wine pH. So the bisulfite form is mostly dominant form of SO2 in wine. And bisulfite will bind to acetaldehydes, glucose, and some metabolic acids. But it's the molecular form, the molecular SO2 form, which only exists about 1 to 6% at a wine pH, that binds or inhibits microbes and prevents oxidations. So at a wine pH between 3 and 4, there's the bisulfite form and the molecular SO2 form. And it's the molecular SO2 form that you really want, which is more abundant at a lower pH. And I know it's an issue, especially with high pH winemaking. When you get 3.8, 3.9, 4.0, it's hard to just acidulate it, because then your wine just becomes acidic. But you need a pH below 4.0 for any type of molecular SO2 to be available in wine. So this is potassium metabisulfite. If you've never seen this before, surely you have though. KMBS is commonly used additive in the wine industry. I mean, all over the place. pH ought to be measured before a KMBS addition is made. So you know your pH, you know how much molecular SO2 you're going to have going into your wine. And then wine may need to be acidulated before using KMBS. Again, pH really needs to be below 4.0. If you're making wine at 4.1, 4.2 pH, it's almost redundant, or it's almost impossible for KMBS to have any effect. There's almost no need to add it because it's not going to do anything. And again, kind of a tip: better to add fewer larger doses than many smaller doses at once. That's just because of a binding effect. It's better to make like a 60 ppm addition, you know, maybe a few times a year, rather than to make many 10 ppm additions. I do not recommend making a 10 ppm addition every week. Just make a 60 ppm addition, you know, every 2 months or so. I'm not saying add 60 ppm every 2 months. I'm just saying that's better to make larger additions than smaller ones. Okay, so quick question real fast. I know that was probably a lot. If you have a quick question, please just unmute yourself and ask. Oh, okay. You can type things in the chat box too if you feel the need. If not, I'll just keep going. So pH is extremely important when it comes to winemaking. Okay, onward. So measuring SO2. This is one that comes across now. If you're adding potassium metabisulfite into your wine, well, you have to figure out a way to measure it now, because it is an important number to know. So measuring forms of sulfur dioxide in wine. I meant to say types here. Anyway, so there's 3 types of SO2. Aside from the forms, there's different types. There's free SO2, which is the available form to protect against wine. There's the bound SO2. This is the unavailable form that doesn't offer any protection in wine. Bound SO2 has already bound to things. I mean, that's the name. Bound SO2 has already attached to a microbe or an oxygen molecule, or you know, some type of acid or a glucose molecule. Bound SO2 has already been bound up. It's already, there's nothing, it's in solution, but it's offering no protection. See, it's your free SO2 that is available to bind to protect against things. And then once you have free and bound SO2 in solution, you just add those together. That's your total SO2. There is a legal limit on total SO2. I believe it's 350 parts per million in the United States. So just know your types. You have free, bound, and total. So we have to measure these now. They're in wine. We have to find a way to measure them. So measuring free SO2, which is, again, your available sulfur dioxide to protect against oxidation, microbial spoilage. Free SO2 is one of the most important measurements to know as a winemaker. If you're making wine and you're adding KMBS into your wine, you really ought to be able to measure your free SO2 in wine. You just have to know it. I mean, I hope you can measure pH. Maybe you can measure titratable acidity. Again, we can all measure Brix. That's pre-fermentation. But once you have wine and you're adding potassium metabisulfite, you need to be able to measure your free SO2. So learn these measurements. Here are a few ways to measure free SO2. One, the aspiration oxidation method, which is probably the most precise method for measuring SO2. Again, I put a link here. I will send these slides out later. That's a link to a YouTube video it'll walk you through how to measure free SO2 using the AO method. Number 2 is the Ripper method. That's a pretty quick way to measure SO2. If you have a Vinmetrica, the Vinmetrica SC300 has an SO2 attachment probe that will measure SO2. So if you have a Vinmetrica SC300, which I think are phenomenal, they're specific tools for winemaking. The Vinmetrica can do a lot of things, and measure free SO2 is one thing it can do. So if you have a Vinmetrica, just use your SO2 probe and you'll get an SO2 number. And then there's something called the titrates test kits, which are little vials that use to measure SO2. It's essentially the Ripper method. I'll get to that here in a minute. Okay, so the aspiration oxidation method. This is, again, probably the most precise way to measure free SO2. And on the right there is a aspiration oxidation apparatus. It's a special piece, it's a special type of glassware to use to measure free SO2. It requires glassware, chemical reagents, and an air pump or a vacuum pump. Either way, you just need some way to run air through that machine. You can either pump it in or vacuum it out. It's not so intimidating once you learn it. And I know a lot of people, including myself, when I was just learning free SO2, I was like, what is this big contraption? I'm not going to know this. But once you really just kind of take it step by step, it becomes second nature. And the AO method, the aspiration oxidation method, is my favorite way to measure SO2 because it's so precise. It's once you learn it, it's phenomenal, and you'll not want to do another way. So here is a on the left is everything you need to measure free SO2. On the right, this picture is just a diagram of how it works. In that round bottom flask, you have your wine sample plus phosphoric acid. In that heart-shaped flask, you have diluted hydrogen peroxide. Those are just the chemical reagents you need. You pump air in, the air liberates the SO2, it pushes it all through the apparatus. The H2O2, which is hydrogen peroxide, captures the free sulfur dioxide. And then from that, you titrate it using a base, usually NaOH. So again, I won't go through everything you need or how it's done, but on the left is all the equipment you need if you were going to build it. And then there's a YouTube video in the link that I'll send out the slides later. We'll show you how to run it. So that's the aspiration oxidation method. I have one quick chat. Be careful for using nitrates, especially on the expiration date. Okay, thank you, Renee. So Renee says, purchasing titrates on Amazon, they have an expiration date. So if you're going to purchase titrates, check the expiration date. Thank you. Okay, next slide. The Ripper method. So the Ripper method is a quick way to measure SO2. This method uses iodine as a titration, and it's a redox titration rather than an acid-base titration, if you know anything about that. The aspiration oxidation method uses an acid-base titration. The Ripper method uses a redox titration. Anyway, iodine is used in the Ripper method. So iodine reacts with SO2 to produce sulfuric acid and hydrogen iodide. Just another way to do it. Always, if you're going to use this method, always protect iodine from light. So iodine is sensitive to light. It comes in an amber jar for a reason. And then if you have iodine, keep it in dark storage. Put something over it or block it out using a black cloth. Light is no good for iodine. So this is the Ripper method. It's just a simple titration. You take 20 mils of wine, 5 milliliters of starch indicator, and then 5 milliliters of phosphoric acid. And you mix it all together in a flask, and then you just titrate using iodine, specifically 0.02 normality. That N stands for normality. There are different normalities, molarities of chemicals. Just know you need 0.02 molarity. And so you just titrate it, and then that's your formula. You multiply how much iodine you use by 32, and it gives you a free SO2 number. And it's pretty quick. I've done it. It's a simple titration. The tricky part is if you're using white wine, it's no problem because white wine turns to purple. You see on those top 2 pictures, just on these 4 pictures on the right, the top 2 is using a white wine. The bottom 2 pictures is a red wine. So if you're titrating red wine to get free SO2, you go from red to kind of darker red purple. It's much harder to see, but if you're careful and you're tedious and you pay attention, you can see that color change, and that color change indicates your endpoint. And once you have the endpoint, you just take, the milliliters of iodine you used, multiply by 32. That's your free SO2 number. So the Ripper method is very simple, very quick, easy way to do it. Okay, the Vinmetrica SC300, one of my favorite machines in winemaking, just because it's so versatile. The people at Vinmetrica make these things specifically for wine and specifically for juice. So I believe that's as far as I know, that's all they do is juice and wine. Maybe some beer, I don't know, but definitely juice and wine. So if you have a Vinmetrica SC300, just use your SO2 attachment probe. This is a very simple way to measure free SO2. The kit comes with everything you need. It comes with the titrants, the acids, Actually, I don't know if it comes with acid. Yeah, the solutions you need, and the instructions are included. So if you have one of these machines, you should have an SO2 attachment probe. Just read through your instructions. It's very simple. You add a little bit of this, add a little bit of that, titrate, put your probe in it, and it measures your SO2. Very, very simple way to do it. I like it. I like VinMetricas a lot. One more quick question. Yeah, best tool. Dan says best tool. I agree. They're great. Titrates. These are things that have the expiration date, so be careful when you're purchasing them. But these are just a rapid way for free SO2 testing as well. It comes with these little vials. I believe there's 10 of them per package. You just fill them with wine. I don't remember if you break them open or if you kind of crush them somehow. A reaction occurs, and it tells you an SO2 number. So this is a very easy way to measure free SO2. But again, they do have an expiration date. Thank you, Renee, for that. So just know that when you're purchasing them. All right. Okay, so adding KNBS to wine. We've talked about the forms of SO2. We talked about measuring SO2, but it never hurts to kind of cover over, well, when do I add SO2? I've been making wine. I have this, this KNBS. When do I add it? And how do I add it? And how much should I add? So we'll cover that here now. So again, KNBS protects the wine. It inhibits microbial growth. It prevents oxidation, and it will boost your free SO2 levels. If you didn't know, and I should probably say, anytime you increase your free SO2 levels, you are ultimately long-term going to increase your bound SO2 levels. So free SO2 goes to bound SO2 over time, because that's its job. That's what free SO2 does. Free SO2 protects the wine. Well, eventually it's going to get bound up and it becomes bound SO2. So just know that and again, 350 parts per million is the legal limit of total SO2 in the United States. So please do not go over that number. In fact, it's kind of hard to go over that number. If you know what you're doing, you won't ever get close to it. But just know, if I'm ever boosting my free SO2, I'm going to increase my bound SO2 over time. And again, total SO2 is just free SO2 plus bound SO2. But just know that. That's why don't add KNBS just every month just to add it. Like, measure it, make sure you have protection. If you don't have protection, add free SO2. But know that by adding free SO2, I'm going to increase my bound SO2 over time. Okay, so when to add KNBS? Quick answer: immediately post fermentation, after pressing. If you're making red wine, you get through fermentation. I've pressed it. Okay, I have wine now. It's in a tank. It's in a barrel. Add some KNBS after pressing. Add KNBS after each racking. Every time you rack a wine, when you move it from one tank to another, or from a tank to barrel, or from barrel back to tank, you're usually picking up oxygen with each movement. So add KNBS after each racking. Add KNBS when free SO2 levels are low. This will require you to know your free SO2 levels. So if you're measuring SO2 and you have, I would say, less than 10 parts per million of free SO2, you might want to make a KNBS addition there. And then add potassium metabisulfite once again right before bottling. So before you go into bottle, measure free SO2, maybe give it a little boost, and then once it's in bottle, you're done. And then again, KNBS can be added to barrels, tanks, carboys, anything, or directly onto grapes. I know some people that do add a shot of KNBS at crush just to kill off some native yeast. That's fine too. Just know that too much will inhibit Saccharomyces cerevisiae, so be careful there. But you can sprinkle it on top of grapes. You can sprinkle it in at crush. But these are the main times to add KNBS. I will get to your question in a minute, Bob. Okay. So formula for KNBS addition. This is very important because you have this bag of KNBS and it's like, how much do I add? Just a scoop? What's a scoop? Well, we measure it, or at least I like to measure it, in ppm. Milligrams per liter is the same thing as ppm. So if I say 50 ppm, that's the same thing as 50 milligrams per liter. But here in purple is your formula for potassium metabisulfite, specifically potassium metabisulfite. You have your desired ppm multiplied by your volume in liters, and you got to transfer it to liters. Don't use gallons, use liters. So desired ppm multiplied by your volume in liters divided by 0.75. That will give you the grams of potassium metabisulfite to add. So here's an example, 50 ppm. Let's say I have 225 liters. I'm going to take that, multiply it, divide it by 0.57, and that gives me 19.7 grams of KBS to add. So that's how much I would add. Now, notice your decimal point on ppm. You can't just put 50 into the formula. You have to move your decimal point 3 places to the left. So a little bit of numbers here, a little bit of chemistry. So 50 ppm is the same thing as 0.05. 33 ppm is the same thing as 0.033, So know your decimal places. Don't just plug in 50 ppm. Don't plug in 50 and multiply by your liters. That will give you a wrong number and you'll have a lot of sulfur in your wine. You have to move your decimal place. So always watch your decimal place. If you want to add 40 ppm, it would be 0.04 multiplied by your liters divided by 0.75. 0.75 is a constant. That's just the percentage of sulfur dioxide in potassium metabisulfite. You see, potassium metabisulfite, or KBS, is a compound, and only 57% of that is actual sulfur dioxide. So that's why we use 0.75 as a constant. So that's your formula, and I'll send these slides out later. If you don't want to do it longhand, this is a calculator. So this link will take you to an online SO2 calculator. You just plug in your numbers, plug in your ppm, plug in your volume, and it will give you how much to add. I do recommend using it longhand though, because you check your work. Now, a lot of people do use a calculator. Just make sure your numbers are correct. Make sure everything's right. Make sure your gallons or your liters are correct. Make sure everything is kosher. And which brings me to the double check. Always, always double check anytime you make a KBS addition. Make sure your decimal points are in the right place. Make sure your gallons or your liters are correct. If you're using it freehand, you have to use liters. Anyway, it'll make sense to you. And then make sure your pH is accurate. Again, if you have a pH of 4.0 and you're adding, 50 grams of KBS into your wine, it's like, you're not really doing a whole lot. You need to acidulate it down. Really 3.8 if you can. And then, make sure you're good from there. So again, always double check your calculations. And then when you even go to make an addition, if you just want to make half, it's always good to add larger doses at once. But if you want to add, maybe half or 3/4 of it, just to make sure you don't overshoot it, because, it's a big difference if 40 ppm or 400 ppm, if you add 400 ppm to wine, it's ruined, bad news. So just make sure your decimal points, everything is in the right place. The zeros are appropriate. Your volume is appropriate. Always, always double check your calculations. Okay, so just quick reminders as we wrap up here. Check your pH. pH really needs to be below 4.0 for SO2 to be effective. Always double check your calculations. I'll say it again, always double check your calculations before you make an addition. And then learn to measure free SO2 in some way. If you are adding KBS into your wine and you're not measuring free SO2, how do you know how much you need to add next go around? Find a way to measure your free SO2. You need a number in some way. And then monitor free SO2 for the life of the wine up until bottling. From post fermentation to storage to aging, you ought to be measuring free SO2 for the life of the wine. And then with that, I believe that brings us to the end. I will stop recording and we can open it up to questions.